Welcome, everybody. Let's get ready to do some experiments. We'll get this rolling here. Get this vortex rolling here. Let me change this up just a bit. Let's see what happens if I put just a bit of a fold in this. There we go. Then you can see more of everything. Nice. All right. Looks like we're ready to go. Experiment time. Hello, Gigabean. How are you this afternoon or morning or evening, wherever you are? Whatever's going on. Let's start just adding, I don't know, a little bit of sodium hydroxide to these flasks and see what happens. Over here on the right, a little drop of base, 2 drops, maybe 3, maybe 4. Oh yeah, a little rainbow action going there, just a bit. Kind of nice. Let's acidify this over here. I'm gonna make this nice and acid over here on the left. We'll make it nice and acidic over here on the right too. Hello, Sarah. I'm doing okay, Sarah. I hope you are too. Thought it'd be time to do some experiments this weekend. Okay, we've got both fairly acidic here. I want to top them off just a bit. Yeah, we did get the rainbow there for a second. There we go. There we go. What am I going to add now? Base. Let's add some base over here on the right. 1, 2, 3 drops. Not much going on. Let's go 3 more. Looks like it's quite acidic. Sure, Sarah. What's up? A little bit of base over here on the left. A little flash of the rainbow over there on the left. Let's see if we can get a little more going on. I'm sorry to hear that, Sarah. Very sorry to hear that. What's happening? What's going on? Hello there, Harley. A little more base over here on the left. So what I'm doing is both these flasks have universal indicator added to them. You can see the different colors that universal indicator displays at different colors. Excuse me, the different colors it displays at different pH values. And what I've added to both flasks at this point is some sodium hydroxide, which is a base. And you can certainly see that, you know, over here we've got a high pH, pH 10. And over here, you know, we got some blue aqua up here, pH 8 or 9, but it's mostly pH 10. Now I'm going to add some hydrochloric acid to both flasks. Hydrochloric acid is the same acid that's found in your stomach. It's just that this stuff that I add, it's like, you know, 100 times more concentrated. So let's add like 5 drops. 1, 2, 3, 4, 5 on the right. 1, 2, 3, 4, 5 on the left. The vortex on the right is larger because the stir bar I'm using is larger. Over here on the left, it's smaller. The vortex is smaller because the stir bar I'm using is smaller. Thank you there, Harley. So now you see I've added enough acid to neutralize, right? It's green. Both flasks are green. This one's a little yellow-green, so this is slightly acidic. But basically, I've neutralized the base. Now check out what happens. Oh, that's cool. XAAD. Tariq. Here we go. I'm going to continue to add acid. I'm going to go 1, 2, 3 drops over here on the right. 1, 2, 3 drops over here on the left. And let's see what happens. Amanda wanted green, and now Amanda wants red. Hello, Heidi Amin. Good to see you. Good to see you. Glad to have you back. So you can see as I added acid, we went from like a greenish or greenish-yellow color to a yellow color. We'll get there, criticize. Here we go. Let's add like 1, 2, 3, 4, 5 drops. 1, 2, 3, 4, 5, 6. Oh, I don't know. I lost count over there on the left. Sorry to hear that, Parth. We'll get there, Tariq. We'll get there. Right now over here on the right, we're at about pH 5. I'm going to add some more acid. Try to drop that pH to pH 3. We got orange over there on the left, Amanda. Here we go. 1, 2, 3 drops over there on the left. Hello, Sophie. We got your red, Amanda. We got like 2 pHs, 3 pHs over here on the left. I'm going to continue to add some acid to acidify that over there on the left. Okay, now Criticize wants some purple, so we need to add some base, right? We're at pH 3, which is very acidic. As I add the base, it'll start to neutralize the acid. We should see it pass through some green on the way to violet if I add an excess of base. You got it right, Dame Abigail. Here we go. Thanks for the like there, Gigabean. Here we go. Let's go. 1, 2, 3, 4, 5 drops of base on the right. That's correct, Parth. I'm using a universal pH indicator. Let's add a bit more base. And we're going to add a bunch of base over here on the left. 1, 2, 3, 4, 5, 6, 7. Let's see what happens over there on the left. Got a little rainbow action trying to happen on the left. Thank you there, Gigabean. I appreciate that. Sure enough, we have green on the right. The base has been neutralized. We had a flash of the rainbow over here. But I think you're right, Dame. I think it has been neutralized. Let's continue to add some base. So there's like 6 drops of base over there on the right. And we've gone way past neutral to pH 10, which is strongly basic. All right, over here on the left. Gigabean, I don't worry about that, man. I'm just in here to have some fun doing experiments. I appreciate people doing that if they wish, but it's not necessary. How's the whirlpool forming, asks Tariq. Watch this over here, Tariq. I'm going to go ahead and turn this button off right here. And when I do that, you see a magnetic stir bar here that is stopped. This machine here is a magnetic stir plate. The way you should think about this is it's a fan on the inside of this box, and that fan spins, and the fan blades are magnetic. So when the magnetic fan blade spins, it spins this, which causes the vortex. Have I tried mass debating? Spooky, I'm not into that. I'm not into debates. Debates are, in my opinion, oral debates are a waste of time. Good thinking requires, in my opinion, good thinking requires long, involved, serious thinking. It does not involve quick thinking, witty thinking. To solve complex problems, you don't want a witty answer. You want a answer that's been thought out over a very long period of time. So I find little use for debates. Dame, I already am. Thank you there, Gigabean. So Matthew, what's going on here is I have added universal indicator to both of these flasks, which mostly contains water. Okay? Mostly contains water. Now, universal indicator is a mixture of dyes that happen to change color depending upon pH. So what I'm doing, if you look up here at the top, you'll see me adding. Right now I'm adding acid to both flasks. And as I add acid, the color shifts from a more blue color, which is a base, through green because the acid neutralizes the base. And if there's an excess of acid, we may see red, orange, or yellow. And indeed, this side looks like it's been acidified. Parth, I'm using 20% by weight hydrochloric acid, which I'm adding now to the left, and I'm adding now to the right. And the base that I'm adding is 20% by weight sodium hydroxide. Dame, I am a chemistry professor. Amanda, teal's tough to get, but we're going to go for it, okay? So in order to get teal, you'll notice right now both flasks are like pH 4, maybe 5. All right, pH 4, maybe 5. And so to get to a teal color, that's going to be somewhere around pH 7 or 8. I'm going to need to add base. So first I'm going to need to neutralize the acids. I'll add 7 drops over here on the left. 1, 2, 3, 4, 5, 6, 7. There's some beautiful swirl patterns. We get a slight rainbow effect going on. I have not, Spooky. That's correct, Parth. You got it. Only New Jersey, or only NJ. I'm assuming that means New Jersey. I apologize if it means something else. We're going to give it a shot, okay? We'll try to make a larger vortex. Son of cool, I think I might be agreeing. I also like carbon dioxide. Carbon dioxide's a pretty cool chemical as well. What's up, Easy? Okay, sorry, only. Thanks for the subscription there, Dame. Hey, I got you your teal. Come on, I got your teal. There it is. I got your teal. Okay. Now somebody said they wanted a larger vortex, so I'm going to try to, this stir bar here, I'm going to try to speed up the stir speed. You can see me doing that right down here. I'm going to turn up the knob, and usually it knocks the stir bar out of orbit, so I'm going to try to get this centered. The more centered it is, the more likely it is to stay in orbit. That's doing pretty. I'm going to leave that for now, okay? That's at about 2/3 speed. Interesting, Frozy VR. Thank you, Amanda, for the subscription. What happens if you drank liquid CO2 inside a dive chamber? Gigabean, I think it would depend on how cold the liquid CO2 is. I mean, I don't know if you can get liquid. It's tough to get liquid CO2 at a fairly warm temperature. All right, I'm adding acid over here on the right. Oh, we got a flash of the rainbow. All right, triple shot. I'm going to try full speed, but you're going to be disappointed. All right, right down here. Here we go. We're going to turn it up. There's your full speed. That's what happens. When I go full speed, it knocks it out of orbit. All right? Samuel, I have no idea. No idea. I'm not a biologist. Not a biologist, so I couldn't help you there. We can turn this. Sometimes I can get this one up at full speed. Here we go. Hello, Spider. Mix both the glasses, says Amanda. Yeah, we can try that. Why isn't the spinner dissolving? I thought it was acidic. So acids, not everything dissolves in acid. Some things do. Quite a few things do. But glass is not one of those things. There is one type of acid. That does dissolve glass, and that's hydrofluoric acid. And I am not using hydrofluoric acid in my experiments, and that's why the glass is not dissolving. Thank you there, Overclock. Make the purple vortex bigger. I'm assuming you mean this one over here, so I'm going to turn this up. I don't mess with radioactivity, Dame. I don't mess with it. You probably could, Frozy VR. Thank you there, Samuel. Thank you there, Dan the Man. See, that's usually what happens when I turn the stir bar up quickly, okay? Okay, so if the CO2 is at like 3 to... Man, I don't know. I don't know what happened if you drank liquid CO2 at like 5 to 30 Celsius. No idea. Connor, I can't make pink. Hello there, Gorilla. All right, Space Chat. Space Chat wants the left one red. So we are going to drop a bunch of acid, hydrochloric acid. It's the same acid that's in your stomach. You can see me adding it over here on the left. And as I do that, the neutral solution, pH 7, will drop. The pH will drop, and we're going to try to get it down to like a pH 3 or so. How the elements are present in nature. So like, is sodium present in the nature as an ion? That's correct, Parth. Sodium is almost always found in nature as the sodium ion with a positive 1 charge. It's going to have the same number of electrons as neon. So it has 10 electrons. A sodium atom, that is, has 10 electrons. It has, sodium, the element, loses 1 electron to become the sodium ion, and that's how it's found in nature. So long, Laya. Make the one on the left. Make blue. Okay, somebody wants blue. Connor, I got your red over here, buddy. Can this chemical dissolve skin? Oh, yeah, if I had enough of it. That's why I'm wearing these gloves. That's exactly why I'm wearing these. So over here, I forgot what the question was. I apologize. Let's see. I have a question, says Peston. How much acid does soda have? Well, Peston, go check out my latest YouTube short. Hello there, Ankita. I love doing chemistry, Dame. Make the vortex on the left bigger. Got it. All right, here we go. I'm going to pop this up. Hey, Tech Buddy, welcome. Can you keep the left glass at base 10 and right at acid 3? And then change them to the opposites. That sounds like fun. Let's do that, okay? Sorry, I'm a little behind on the comments here. So we're going to go, I forgot which was which, but over here we're going to make this one. We're going to make this one over here violet, and then we're going to switch them really quick, okay? So we got, I'm going to see if I can turn this one all the way up because somebody asked that. All right. So not sussy, what we have going on here. Okay, there's lots of questions going on. So let me start from the start, and then I'm going to do the experiment that was suggested. So what's happening here is I have 2 flasks with water in them. They're on a magnetic stir plate. The magnetic stir plate, these boxes here, so to speak, have fans in them with magnetic blades. They spin. When those spin, they spin little magnets on the inside of each flask, and that causes the water to spin. In each flask of water, there's universal indicator. Universal indicator changes color depending upon pH, which is just how acidic or basic something is. You can see here, right here, you can see the different colors and the different pH values. So in this flask, it's pH 3, which is very acidic. In this flask, it's pH 10, which is very basic. I agree, Spooky. Okay, now we're going to go ahead and to this flask over here, which is acidic, I'm going to add a base. To this flask over here, that's basic, I'm going to add an acid. So here we go, 1 drop each. Drop of acid on the left, drop of base on the left, drop of acid on the right. You can see the blue color from the base going through, and the acid that's present is consuming it. Here we go, 1 drop of base on the left, boom. 1 drop of acid on the right. 1 drop of base on the left, 1 drop of acid on the right. And you'll notice the pH of this has gone up from 3 to 4 or 5. The pH of this has gone down from 10 to maybe 8. Parth, I already did that. Okay, here we go. A drop of acid on the left. A drop of base on the left. A drop of acid on the right. Drop of base on the left. Drop of acid on the right. The goof, yeah, I do that a lot. I work with that a lot. Drop of base on the left. Drop of acid on the right. Hey, thanks, Tech Buddy. Appreciate it. Thank you there, Jeff Harrison. What am I doing for 1 million subs, Gallant? I don't know. I'm just doing science experiments, bud. And if I get to 1 million, I get to 1 million. If I don't, I don't. I'm having fun either way. So acid changes the pH and the base high. That's right. Acid lowers the pH and base increases the pH. Interesting. Thank you there, Gigabean, on that information on liquid CO2. Can the magnet mix up the beverages? Space Chat, I apologize. I'm not sure I understand the question. Happy birthday, Neil Grow. Thank you there, Parth. Why does the left have a tinier vortex? Because it has a tinier stir bar. Here, I'll turn them off. There, they're turned off. And you can just see it's a tiny stir bar versus this one over here that's big. It's kind of fun when they're turned off to go ahead and add in. I'll add a bunch of base over here, and we'll add a bunch of acid over here, and we'll just kind of see what happens. It's kind of neat to see this. Yep, VM5, Merry Christmas to those who celebrate. Thank you there, Lila Place. Yeah, you could, Phoenix, as long as you kept everything, food safe. Yeah, you could actually use these stir bars for mixing cocktails. It'd be fun. So yeah, in this case, I've got the stir bars turned off, and what's kind of interesting, in this flask, we now have a pH gradient from pH 3 to pH 7, and on this side, we've got an interesting condition where the middle is high pH and the outer sides are neutral pH. Matt, I bought this stir plate and stir bar for like $40, so if you just Google, here, I'll show you, Matt. INTL Lab Magnetic Stir. I got mine on Amazon. Thank you there, Gigabean. I appreciate the information on liquid CO2. So is the acid that you put into the flask safe? Kareem, it is. you know, with caveats. So the acid that I'm adding to each flask is hydrochloric acid. It's the same acid that's found in your stomach, but you might notice that I'm wearing gloves. Because if I get some of this stuff on my hand, it's not, you know, it's gonna irritate my skin. Am I trying to make it neutral? Honestly, Mr. Giraffe, I'm trying to do, yes, Matt Howard, I am. I'm trying to do things that you folks find interesting, to be honest with you. Krishang, I'm loving some nitric acid too, but I do not have any. I wish I had some. I wish I had some. That's about 40 bucks. That's right. That's right. Hello, it's about $40. All right, Stefan Verse, here we go. This is for you. I'm going to turn this up max. Here we go. The one on the left is going up to max speed, and the one on right is going up to max speed. And that's usually what happens. The stir bar gets knocked out of orbit. So I'm going to turn this one not to max speed, but I don't know, maybe about 2/3 speed. What happened if I put metal in both? Probably not a whole lot. Satori asks, can I drink it? You can, but your afternoon's not going to end well. One of the dyes contained in Universal Indicator is a laxative. So, you could drink it, but you might have an uncomfortable afternoon. I don't know what a looped stream means, lazy doggo, so I can't answer the question. Hello, Low SG. What's the baddest thing that can happen in this experiment? Hello? Probably the worst thing that could happen is I would spill some of the concentrated sodium hydroxide on my skin. That would hurt. But it would take a while, and it's not going to happen right away. Millicent, thank you for the subscription. The pH of stomach acid is about 1.5. Aiden, you can buy these on Amazon. Thank you, Archie. That's funny. Hello, who was that? Oh, those comments are coming through a little quick for me. Hello, Happy Face. Oh no, lazy. This is happening live right now. I'm gonna try to make a rainbow commenter. Javier, if it gets in my eyes, I'm not gonna like it, which is why I'm wearing safety goggles. And then somebody is asking, how do you do this? So let's talk about this. Thank you for the sub. Hello. The pH of stomach acid, SL, is about 1.5. Hello, Noel. You can drink it, Tomislav, but it doesn't end well for your afternoon. One of the dyes in here is a laxative. So what's happening here is I have two flasks with universal indicator. Universal indicator is also known as rainbow indicator because it displays all the colors of the rainbow. Like that one. All right, we got the full rainbow. Safety third. Come on, man. It displays all the colors of the rainbow at different pHs, okay? At different pHs. Alf, I decided to do science because I think experiments are just fun. They're fun to watch. They're fun to do. So what I'm doing to change the color, to change the pH, is I am adding either acid, which is going to make it more red, or I'm adding base, which is going to make it more blue. Here, over here on the left, I'm going to add a bunch of base. Here we go. To the flask that's neutral, notice it was pH 7, which is green. Can both revert back to neutral, and is it safe to drink? It's not safe to drink at neutral because one of the dyes is a laxative. Tripical, I'd like to learn how to do that too. I'm adding base over here on the right. I'm not what we call a synthetic chemist. Look at that, we got the rainbow. Come on, baby. Yeah, sure, Stefan Verse, I'll do that. Felicia, what will happen if the acid touches me is it'll irritate my skin. The skin will get really red. Just eat my skin away. But, it's not going to, it's just going to irritate it. Because I would just add a few drops. If I soaked my hand in a vat of this acid overnight, it could eat my hand away to the bone, but it would take some time. It's not going to happen right away. So I can dip my hand into this stuff and rinse it off very quickly and, put a bunch of baking soda on it to neutralize the acid, and I'd be no worse for the wear as long as I did it quickly enough. Can I drink purple? I wouldn't, Emma. Okay, here we go. Let's add a little bit. I did, Gigabean. This is not pre-recorded, Classic Gamer. Here we go. We're going to add 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Drops of base to each side. We're going to check out what happens. A little rainbow action. I'm loving it. Alf, I decided to do science when I was in college. I was taking a general chemistry class, and one of my professors, his name was Dr. Schultz, did live chemistry experiments during class, and it blew my mind. And I thought, that's what I want to do with my life. No, hello, I cannot make it black, brown, or white. Thank you there, Jermaine. I appreciate that. Thank you there, Stefan's verse, for the... So which one is the most dangerous? So which dye is the one that's a laxative? I don't know which one's dangerous. I haven't sat down and read through the, the toxicity of all the different compounds that are in here. But I can tell you they are thymol blue, methyl red, bromothymol blue, and phenolphthalein. Phenolphthalein is the one that's a laxative. This used to be the main ingredient in X-Lax. You add them all together and you get universal indicator. Hello there, Shedrickson. You're welcome, Satoru. Hello, Shedrickson. What happens if you mix them? Hey, let's do that. Let's mix them. Here we go. We're going to mix them. So what we're going to do, this is kind of fun to do. If you've been paying attention, you know the answer to this. I'm going to make this one over here pH 3. This one's already pH 10. And then what we're going to do is we're going to mix them. We're going to mix them in a flask. Here we go, baby. Let's do it. Acid versus base on skin, which is worse? Gigabean, it depends on the acid or base. It depends more on the acid or base than it does on whether the substance is acidic or basic. Thank you there, Goin. I appreciate it. What's my favorite science experiment? Whichever one I'm doing at the time, Savannah. Whichever one I'm doing at the time, which is most often Coke and Mentos. Okay, what college did I go to? I got my PhD at the University of Michigan, Aaron, and my undergraduate degree was at Bloomsburg University in Pennsylvania. Thanks for the sub there, Satoru. Thank you there, Alf. Is it possible to drink the green one? Hello, you can, but you're going to sit on the toilet because one of the dyes is a laxative. Okay, here we go. Hello, Andrew. We're going to take some of each of these. I'm going to take some red and some violet. We're going to mix them together. And if you have been paying attention, you know what's going to happen. Mix in red and violet. What color are we going to get? Mix in red and violet. What color are we going to get? Mix in red and violet. What color are we going to get? Here we go. Keep mixing them up. Keep mixing them up. Keep mixing them up. Red and violet. Sorry, I'm not paying attention real much to the comments right now because I'm paying attention to the experiment. Looks like the acid's a little stronger than the base, but there we go. You get like a yellow-green color, and that makes sense. You get a slightly yellow-green color. Let's make it green. Just going to add a bit more of the base here to try to make it green. I don't know how much I'm going to need to add here. Let's see. Maybe 3 squirts. Yellow-bellied coward's funny. A little more green, right? Because when you mix an acid at pH 3 with a base, acid at pH 3 with a base at pH 10, they should neutralize each other. So it looked like we got a little bit of yellow-green, so we weren't quite exactly neutral. We're like pH 6.5 or so. That's cool, Alf. I hope you do. I hope you do. Here we go. We're going to add drops of base over here on the left. Let's see if we get the rainbow going on. Come on, baby. We want the rainbow. Thanks for subscribing there, Just. Thank you there, Coledale. Yes, Gigabean, there is such a thing as pH 0 and -1 or pH 15. What happened if you drank a base? We do. We do drink bases. It just depends on which one. Like, for example, if you ever had an upset stomach and you drank some of this stuff, you've drank a base. Milk of magnesia is a base. So probably would just go down to your stomach and neutralize some of your stomach acid is what it would do. I'm from the United States, Alf. Here we go. Let's add some base over here on the left. Yeah, let's do it. Khan, we are going to slow down one of the mixers, okay? Can you drink alkaline 14? Yeah, if the amount, no, I don't, come on, be real careful here. You can, however, you want to make sure that if you do that, the amount of base that's present is really low. Generally, it's not a good idea to drink something at that high of a pH. Hello, Specco. Straight, what I am experimenting on is using acid-base indicator. And then I'm adding either acid or base to change the color. Look like we got a little rainbow action going over there on the right. Looking nice. Oh, that'd be a good idea. Hello. I may try that at some point. Joshua, thanks for the subscription. Alkaline 14 soap FG would be a little high. I think that'd burn your skin. So usually soap is a little lower than that. Maybe pH 8. Ooh. I'm not doing that, the Goofia. I mean, I don't want to sit on the toilet the rest of the day. Why is hydrogen peroxide so dangerous to drink, Gigabeam? Because it is a really good oxidizer, and it oxidizes you. We got it, Fazuli. I'm sorry, I know I'm not saying your name right. That's right, FG, alkaline 14. I got some, this is actually higher than pH 14, this stuff right here. I'd have to do a calculation to tell you what it really is. It's close to like pH 15. Felicia, if the mixture, not these mixtures are dilute enough, nothing would happen. These are the ones that I'm wearing gloves for. If these get on my skin, it's really going to irritate them. I'd say it'd probably start irritating my skin in like a minute or so. So if I get some of this on my skin, I quickly rinse it off. I've got some water hanging around where I can do that for. The lowest pH level, Stefan Verse, I think fluorantimonic acid is the most acidic substance known. And if I remember correctly, its pH is roughly negative 20, but I'm way guessing here. But I'm pretty sure it's fluorantimonic acid. What numbers can fish swim in? Wick Lost Wolf, I'm guessing here. And I would think that people who own fish should be able to tell me better, but I'm thinking right around, well, okay, I mean, fish out in nature, they got to be able to swim in like pH 5.6 because natural rainwater is pH 5.6 because carbon dioxide dissolves in natural rainwater. The pH of soda is going to be 2 or 3. Mr. G wants me to mix the rainbow, so I'm going to happen. There we go. Mix it up. Well, the most dangerous acid would probably be the most dangerous one I can think of off the top of my head would be HCN, hydrocyanic acid. That's because the vapors from that, if you inhale those, they displace the oxygen from hemoglobin, and then your blood can't carry oxygen, and you basically suffocate if you inhale that stuff. What pH water drink? pH for water, you can go all the way from like pH 4 or 5 up to pH 8 or 9. I wouldn't call that one dangerous there, Andrew. Under the right conditions. Sure, Specco, I'll try to make it neutral. Let's turn this one on here. I'm going to add a bit of acid here. We'll get this spinning. See if this one gets neutralized. See if I got enough acid in here to neutralize the one here on the left. Gigabean, great question. I don't think I know what the most basic thing is. The most acidic food or drink, asks Alicia. What a great question. Probably vinegar is getting down there. So vinegar is going to be around pH 2. Use a YSI probe to find some freshwater lakes with thriving fish populations around 5863. That sounds about right. I used a YSI probe in my PhD studies. It was an oxygen probe. So we did studies on oxygen evolution and photosystem 2 in green plants and higher plants. Well, there we go. Andrew. Well, that's a good question, Patsy. I'm not sure. I think a lemon or lime just might be more like lime juice or lemon juice just might be more acidic than vinegar. But vinegar's down there, man. Is pink bismuth basic? So you're asking, is Pepto-Bismol basic? I don't know off the top of my head. Hello there, Shedrickson. Arrhenius, that's how I pronounce it, Dylan. I'm probably not right, but that's how I'll try there, Savannah. Hello, Shedrickson. Hello, Mano. Thank you, Satoru. According to this scale, what's the highest negative acid? That'd be fluorantimonic acid. Hello, universe. Hello, Sarah. All right, Specco, here we go. Let's try to get the rainbow. I'm going to make both of these acid. I think I'm going to... Boy, this one over here on the left is not... It's not going acidic. I'm having to add a bunch of base to that one. Fenny, that's a good idea. What's a negative acid? Lots of different acids can have negative pH. I think you're asking negative pH. I'm not sure. I've not heard the term negative acid, so I don't know what that means. But acids, you know, pH refers to the concentration of protons that the acid produces. How you doing there, Drip King? All right, let's see if we can get the rainbow over here on the right. Here we go. Here we go. Let's go like 3 drops. 1, 2, 3. See if we get the rainbow. I don't think we did. I missed it. I'll try again. We will try again. Musical. My qualifications are I have a BS in chemistry education. I have a master's degree in chemistry. And I have a PhD in physical chemistry. In chemistry, and the subdiscipline is physical chemistry. So those are my qualifications. I got my PhD from the University of Michigan. So meme man, how a negative pH is possible is pH is defined as the negative logarithm base 10 of the proton concentration. Protons are what acids produce when they're dissolved in water. So if the proton and the unit of the concentration, we got a little rainbow there going on. Proton concentration is measured in units of molarity. So if I have an acid with a molar concentration of 10 molar, the negative log base 10 log base 10 of 10 is 1, and the negative of that is negative 1. It's just that simple. What's the most failed experiment I've ever done? Savannah, this is not cocky, okay? This is philosophical, so bear with me here. I like to say I've never had a failed experiment, only new observations. So bear with me here. In science, it's really true that you can never have a failed experiment if you have the right scientific philosophy. And in my opinion, the appropriate scientific philosophy is that we want to see what is and describe what is and explain what is as best as we can. Therefore, when we do experiments, if we go into those experiments just trying to see what is, we can't fail. All we're going to do is we're going to see what is, what happened in the experiment, try to describe what happened in the experiment, and try to explain it. The acids and bases I'm using are hydrochloric acid, 20% by weight, and sodium hydroxide, 20% by weight. No, Fenny, those are all colors that are able to be displayed by this particular indicator system. I don't know if it's the rarest one, hello, or not. I do not know. All right, let's make this one basic over here. Let's make this one basic over here. Get her spinning. Turn off the spin. Add a bunch of acid. Yes, there is a smaller propeller, Savannah. No, Banana, we drink things other than neutral all the time. I'm going to add a bunch of acid to the top. We're just going to kind of watch what happens, okay? Let's just watch what happens. I don't know what that means. Somebody called me the Sigma at chemistry. I don't know if that's a compliment or a put down, but I'll take it as a compliment. We are not creating a buffer, Bill, because we are reacting strong acid with strong base. I'm trying that here, Gigabean. Looks like I'm trying that at this point. What's my most favorite acid? What a great question. Probably carbon dioxide. When carbon dioxide dissolves in water, it produces protons into solution, and I think carbon dioxide is a very cool compound. Thanks there, Xylon. I appreciate it. Thanks for teaching this old man some slang. There we go. I add a little bit more acid to both. See what kind of interesting things we get. What are we doing? What are we doing? The water's not spinning because I turned off the stir bar. What I'm doing here is I have two flasks. Both flasks have water in them. Flasks have water in them, and both flasks also have universal indicator in them. Universal indicator is also known as rainbow indicator, and it changes color, as you can see here, depending upon pH. Now, pH just tells you how acidic or basic something is. So both these flasks have a variety of pHs in them, all the way from pH 10 down to pH 3. Below pH 7 is acidic. Above pH 7 is basic. At pH 7 is neutral. Sameep, isn't the lowest pH acid most dangerous? Yes, if you have a very low pH acid, you have a high concentration of protons, and those high concentration of protons are going to chemically react with you, and that's probably not a really good thing. Looks like we basically had both flasks neutralized. Let's make them acidic again. Here we go. Add a bunch of acid here. Add a bunch of acid here. What will happen if we pour mercury and liquid nitrogen? The mercury will solidify, Sorty. I've seen that happen before. It's kind of cool. No, this does not explode. Hello, just check them out. I got a new video out yesterday. I was testing the two different, I tested Diet Sprite and regular Sprite for acid to see which one has more. Thank you there, Banana. The acid I'm using is 20% by weight hydrochloric acid. The base I'm using is 20% by weight sodium hydroxide. Andrew, I'm loving it. Nice, nice, nice. Okay. I see. Very nice. So Stefan's verse said, there's no failed science experiment, right? What about the demon core then? Absolutely. In terms of human life, the demon core, quote unquote, experiment is definitely a failed experiment if you're focusing on human life. Philosophically, we learned some things from the demon core experiment, did we not? And in that sense, although I say this tentatively because, a person died during that experiment, but nevertheless, even with that person's death, we still learned something. We certainly learned what not to do. That's correct, Cat Lover. We'd have and this one, at this point, because it's green, it's neutralized, we'd have sodium chloride if we evaporated it. Yeah, you can do this in a middle school classroom. Yep. Probably be better to have the teacher do it than the students because of the concentrated solutions I'm using. What if you touch a base? Satori, what's going to happen is the base is going to react with the oil in your skin, and it's going to make soap, and so you're going to start to, feel soapy or slippery sensation on your fingers. And once all the oils react away, the base will start, reacting with your skin, and that'll irritate your skin. Yes, Wicked, this would work with alcohol. The colors are going to look a little different. I'm not sure if hydrochloric acid dissolves real well in alcohol, and I don't think sodium hydroxide dissolves real well in base, so these solutions would probably have to remain aqueous. About what pH is Gatorade, I don't have a Gatorade bottle in front of me. I don't know if it has acid in it or not. My guess is like pH 5 or 6, but I don't know. Cool there, Attila Cooks. So why do we use magnesium as an antacid and not sodium to neutralize acidity? What a great question. The spinny thing under the glass is just a magnetic stir bar. So probably because it's easier to, like you don't want to eat sodium hydroxide, but magnesium hydroxide, what's nice about that is it doesn't dissolve really well. And so you can have these solid particles suspended in a fluid, and it's kind of like, swallowing a solid rather than a dissolved substance. Would be my guess why they use magnesium rather than sodium in antacids. I don't know. Hello. I do not know what happens. Do not know. I guess we could do that experiment. Do I have stuff down here to do it with? This is kind of fun. Let's switch this up just a bit. Oh, this will be my last experiment for the day. This is kind of fun. All right, let's get this thing on here. Sorry, the flask is going to be a little bit dirty. Let's get this one on here. Okay. I'm going to get some water going in this flask over here on the left. There we go. Get stir bar going. Let's get some water in here. All right. Thank you there, cat lover. Sorry, folks, I'm not really checking the comments just yet because I'm trying to make this look pretty. Oh, my hip is killing me. Okay. Does the TDS of the sample water affect this test? Sure it would. It absolutely would. What if I put uranium and plutonium in one of the flasks? Come on, man. I ain't gonna mess with that stuff. Okay, here we go. I love this experiment. So here's my flask here. Let's zoom in on it. All right, it's not perfectly balanced, but it's gonna work. Okay, now to this flask, I'm gonna add some universal indicator. So remember our colors that universal indicator shows at different pH values. I'll put it over here so we can see it. These are different colors universal indicator shows at different pH values. All right. So this is pure water here, although the flask wasn't cleaned out, but let's see. So universal indicator's green. We'll put it in here. And sure enough, it looks like our water is just a bit green. Yeah, this is normal water. This is normal water, okay? So we got our green color here. I'm not messing with plutonium. Come on, man. I am not messing with that stuff. Okay. Why is it called universal indicator? It's called universal indicator because it displays all of the different colors. It shows the universe of colors, the rainbow spectrum of colors. Shows all those colors there, okay? So yeah, we got them both green. They're both neutral, all right? It's all right, Alpha Man. Okay, we are Jupiter. We're going to put milk in it, but not the kind of milk you probably think. The milk we're going to stick in here is called milk of magnesia. So people drink this stuff when they have an upset stomach. This stuff here, it's a base. I'm going to show it to you so you know it's a base. So I'm shaking it up. We're going to add a squirt of this. Classic edits. The pH of water is usually about 6 because carbon dioxide dissolves in the water, and carbon dioxide's an acid. Okay, here we go. Here's the milk of magnesia. You can see it's like a creamy white color. It's going to go in here. And it's creamy white because there's a lot of undissolved solid particles in it. And you can see its pH is increasing. It's blue now. It's a blue-colored substance. Try to get the light fixed on it a little bit better. There we go. We can see the blue a bit better if I move that there. Okay? So now it's like violet, isn't it? Let me get this shining on it too. See, it's like a violet color, okay? And it's violet because the magnesium hydroxide is a base. And when people drink that magnesium hydroxide, it neutralizes the acid, okay? So now what I'm going to do is I'm going to add some stomach acid to this. Okay, here we go. In goes, let's go 1, 2, 3 drops. So there's the acid. Now there's still some solid magnesium hydroxide particles that will neutralize that acid. And sure enough, it's doing so. So the acid has been neutralized, and now some of the solid magnesium hydroxide particles in there. I can tell they're still in there because you can't, you can see through this solution. I can't see this through this one because of the antacid particles that are present. So those solid particles will continue to dissolve, and our pH should continue to rise. It's like at a pH 8 now. If we let it go, it is going to continue to dissolve and get back to pH 10. Not going to happen, banana. Not happening, Ulysses. So yeah, we're up to like pH 9 or 10 now. Here we go. What happens if you drink D2O gigabean? If that's all you drink, you die. Here we go. I'm going to add some more hydrochloric acid. 3 drops up here at the top. 1, 2, 3. In goes the acid. Now let's watch the milk of magnesia neutralize the acid. pH 10 means the proton concentration is 10 to the minus 10th molar. I don't have any iron chloride, universe. Jupiter, pH 10 means the proton concentration is 10 to the minus 10. pH 9 means the proton concentration is 10 to the minus 9. I don't have any sulfuric acid, Ulysses. You're welcome, Jupiter. So to figure that out, hello, what you're going to need to do basically is you're going to take 10 to the minus 1.35 times 10 to the minus 3. You're going to multiply that by 0.1. And you'll take the square root of that product. So you're going to take the square root of 1.35 times 10 to the negative 4 is what you'll do. That'll be essentially your proton concentration. Maybe not. Your Ka is a little too low. Yeah, it's a little tough to answer here without writing some things down. Okay, here we go. Let's add a couple drops of hydrochloric acid. Here we go. 1, 2, 3. In goes the acid. Let's watch the magnesium hydroxide neutralize the acid I've added. There it goes. It's neutral again. Hello, I can't answer that question on a live. If I could do it, but it's gonna ruin the live for everybody else. I don't have any Coca-Cola Drift, man. I don't have any magnesium metal random. But you can look through my lives, or excuse me, my YouTube shorts random. I do burn some magnesium in one of my YouTube shorts if you want to check it out. So how phenolphthalein reacts with acids and bases. Here, let's add a couple more drops here. So phenolphthalein is a ring-shaped molecule in an acid. So in an acid, when... Thank you there, RL. Go blue, baby. Wasn't that great? Wasn't that great last week? Oh, crap. Thank you there, Satoru. Sorry, I got off track here. Somebody reminded me of just how fun last week was. Karar Khan, I usually do this on the weekends. Cat lover, what's that gonna do, man? Your blood is just slightly basic. Pogify, I already have a YouTube short out on the Briggs-Rauscher reversible reaction. Sorry there, hello. I'm not going to answer the question. All right, we're getting near the end of the live here. And at the end of the live, what I do is I flip the camera around. I'll let you see my ugly mug, and we talk for a little bit. Yeah, that's what's coming, just so you know. So fair warning, if you don't want to, see an old man in his basement, now's a good time to get the heck out of here. But yeah, we'll be talking. We're going to be talking. What's the charge of technetium ions? I don't know. What is the... Oh, there's the technetate ion. So it's probably similar to magnesium. Because just like there's a permanganate ion, I think there's a pertechnetate ion. So like in the pertechnetate ion, it'd be +7. The pH is alcohol. Alcohol is neither acidic nor basic, so we'd probably call it pH 7. I'm going to put a little bit of universal indicator, magnesium hydroxide in here. See if we can't get the basic color back. And watch it neutralize the acid a couple more times. Hey, come on, man. Rich Kids on the Block just sent me a gift. Come on, baby. That's really nice of you. I don't know what to say. Thank you so much. That's me 100%, Daniel. Come on, baby. Daniel just called me a nerd. You know it, brother. I am 100% nerd. I own it. I definitely own it. What if I drank the strongest acid? Depending on how much I drank, I'd probably die. All right, here we go. Let's add a few drops of acid here. And let's watch the milk of magnesia neutralize it. Do I think the island of stability exists? Well, sure it does. There are certain... I think you're referring to the island of stability in terms of atomic nuclei. You got it, Jupiter. So yeah, I mean, there are atomic nuclei that exist. Man, that's cool. So long, banana. Hey, Rich Kids, come on, man. I appreciate it, but it is definitely not necessary. Thank you. Hey, it sounds like my wife's home, so I'm gonna end this live soon. So let me go ahead and flip the camera around after you watch this fade back one last time. There we go. All right. So long there, Ulysses. Turn this baby around. How's everybody doing today? How's everybody doing today? Just a couple more minutes. We'll hang out. I got my reading glasses on here. Oh, my hip is killing me. So long there, hello. Thank you, Pogify. Thanks for hanging out. Thank you, Polymath Science. You know it, Hyper Cat. Come on, baby. Nerd level is off the charts. I got negative pH nerd value here. Thank you there, Driftman. I appreciate it. Hello there, oh yeah. Hello, Israel. Rich Kids on the Block, where you can buy an Intel Lab magnetic stirrer. Intel Lab, send me a email at tommytechnetium@gmail.com, and I'll send you a link where you can buy one of these magnetic stirrers. All right. I am musical, guys. I'm going to be 60 in less than half a decade. We'll put it that way. Thank you there, Bronny. What's up there, Philip? Thanks there, Rich Kids. Appreciate that. Thanks, Universe. Hey, Israel. Do I think the Planck length exists? Yeah, I mean, sure. Yeah. What happens if you eat sodium fluoride? I've eaten sodium fluoride before. I've swallowed a little bit of toothpaste. No worse for the wear. As long as you don't eat too much, right? The dose makes the poison. So long, hello. Yes, I am active, Pogify. I try to stay active. But being active doesn't help. Like, I can't read a thing now. It doesn't help your eyes, that's for sure. Hey, somebody drop in the chat the score of the Steelers game. Steelers versus Browns. What happened? I came on during the, after halftime. Oh, cool, Stefan's verse. I wish I could see y'all. It'd be neat if you could like if I could tap on one of your comments and then have you pop up in the corner. I could talk to one of you. That'd be cool. I have not, Universe. Steelers are up. How much, Andrew? How much they up by? Oh, how do I do this? How do I add a comment? Hold on a second. Let me see if I can figure this out. I'm doing the plus. Nope. That didn't do it. No, that ain't going to work either. It's just Rich Kids. It's just the name of my channel. So it's Tommy Technetium, no spaces, at gmail.com. I'm not. I've gone an hour. I usually quit after about an hour. It's all I can handle. I can't stand standing looking in. Oh wow. Okay, thank you, Andrew. So that game's probably over. I mean, like, yeah, I got. Oh, we're gonna end this soon. I can't stare at a screen much more than an hour. Marshall, usually around this time. So it's either going to be Fridays, Saturdays, or Sundays around this time. I like Sunday afternoons. Hello there, Max. All right, y'all. I'm heading out of here. I want to go see my wife. She's been working all day. I want to say hello to her, talk to her a little bit. So thanks for hanging out and checking out some here. Let's just check it out one more time. Checking out the beauty of science. It's all around us. Pay attention to that world around you, folks. It is definitely beautiful. Excuse me. So somebody wants a countdown. Let's do it. Here we go. So long, folks. We'll see you next time. All right. Bye-bye. 10, 9, 8, 7, 6, 5, 11. This is hilarious. 4, 3, 6.5. That's hilarious. 2. Thanks for the subscription. 1.2.